In this video, we're going to do more with coordinate proofs, and we're going to look at how to determine if a triangle is a right triangle on the coordinate plane. So some useful formulas are below. So we've used distance formula to show isosceles triangles, scalene triangles, and equilateral. Today we're going to look at using slope formula to show right triangles. And midpoint formula we're really not going to be using for these triangle proofs, but we will use later for some other types of proofs. So if I'm trying to show right triangles, that means I need to have one right angle. So what I'm going to do is I'm going to show that the lines are perpendicular because perpendicular lines imply right angles. So we need to show that we have perpendicular lines by showing that we have negative reciprocal slopes. So that's really what's going to happen. So we're going to show one right angle by showing negative reciprocal slopes. So that means slope formula. Now, if we want to show, if we look at this example, this wants us to show that we have an isosceles right triangle, which means we're going to do two things. To show the isosceles part, we're going to use distance, like we did previously, to show two equal sides. And then for the right triangle, we're going to use slope to show negative reciprocal slopes. So flip and negated slopes. So let's go ahead and do this. So it doesn't matter which one you show first. If you're trying to show that it's an isosceles right triangle, it doesn't matter if you want to show that you have it being isosceles first, or if you want to show that it's a right first. It doesn't matter the order. You do have to show both. So it doesn't really make a difference. But the first step, regardless, is going to be to plot our triangle and to look at it, make sure it looks that it's isosceles right triangle first. So I have 4, -1. So when I do this, I'm going to make sure that I'm labeling my letters. If for some reason you ever have a picture where there isn't letters with your coordinates, I always recommend creating your own letters. I just think it makes all of your calculations easier to label. 2, 4, 6, so this is B. And then I have 1, 3. And really, the first thing I do when I look at my picture is, okay, I ask myself, does it look like what it's supposed to look like? So do I have an isosceles right triangle? Does it look like an isosceles right triangle? And to me, yes, it does. So that tells me, okay, I'm on the right track. I've graphed my picture correctly. So I'm going to go ahead and start with the right triangle part since that's the new part. So I'm going to just go ahead and I'm going to say the first thing I'm going to do is the right triangle. So I'm going to use my slope formula. Oops. Let's try that again. So slope formula is the change in y's over the change in x, or y2 minus y1 over x2 minus x1. And I want to look at my picture and decide which angle do I think is the right angle, because those are the two sides that you should find the slope of first to make sure that you do get the right angle. So I look at this and it looks to me as if BC and AC are the perpendicular sides. So that's what I'm going to go with first. I'm going to go ahead and find those slopes, and as long as those are negative reciprocals, then I'm good to go. So I'm going to go ahead and I'm going to use BC first. So I'm going to find the slope of BC. Notice I'm putting BC as my subscript so that it's clear that that's what I'm finding the slope of. I like to draw my little brackets up here. So it's going to be 3 minus 6 and then 1 minus 5. Make sure whatever order you subtract, you're consistent. So then I end up with -3 over -4. So this ends up giving me 3/4. So now I'm going to find the slope of the other side, AC. So AC, I'm going to do 3 minus -1, being careful about that negative, and 1 minus 4. So I end up with 4 over -3, which is perfect because when I compare these now, these two slopes, I see that these two slopes are flipped and negated, meaning they're negative reciprocal slopes, which means I have a right angle. So that's good. These are negative reciprocals. So negative reciprocal slopes make perpendicular lines, which means that angle C is a right angle. So that means I do have a right triangle, and I'll wait to talk about the right triangle afterwards once I write my conclusion. So now, to me, that means the two sides that should be equal are these same two sides, because in a right triangle, the third side across from the right angle is always the longest side. It's the hypotenuse. So that can't possibly be the equal sides in the isosceles triangle. So I really just need to show that BC and AC are congruent. So that's going to be my next step. So now I'm going to show the isosceles triangle. If for some reason this just said to show that it was a right triangle, I would be done. I would just have to write my conclusion. Triangle ABC is a right triangle because it has a right angle. But because it asks for isosceles, that's why I have to do this extra step. A lot of times you won't have to do this extra step. It'll just be show it's a right triangle, and then you just do this first part. But for this one, since I'm also trying to show isosceles, I'm going to go ahead and write down my distance formula. So change in x is squared plus change in y is squared. Oops, I said change and I put plus. And then now I can plug in, and I'm going to use the same side. So I'm going to say distance of side BC. So I'm going to just zoom out a little bit so I can still see my coordinates. So BC, I'm going to subtract my x's. So I have 1 minus 5. And I'm going to subtract the y values. 3 minus 6. I'm going to simplify inside of those parentheses, so I get -4 and -3. Remember, when you square, these should be in parentheses, so a negative times a negative becomes a positive. So 16 plus 9, so it gives me the square root of 25, which comes out nicely to 5. If it didn't come out nicely, I would leave it, I would put it in simplest radical form. Oops, I didn't mean to label that. I know it should be 5 since I got 5 for this, but we definitely want to make sure that we get 5. So now I'm going to go ahead and do the other side, AC, and I'm hoping that I do get 5 because that's what I should get. So now for AC, I'm going to subtract 1 minus 4. And 3 minus -1. So I end up with -3 squared plus 4 squared, which is good because it's looking just like this other one. So that means I'm going to have 9 plus 16, which is the square root of 25, which is 5. So that's good. Now I can label my picture now that I know I got the same calculation. So now, since these sides are equal, this shows that the triangle is isosceles. And since it has a right angle, we know that the triangle is also a right triangle. So now we can write our conclusion down here at the bottom. And basically start off by whatever it tells us. So we're trying to prove that we have a right triangle, or isosceles right triangle. So that's how I start my sentence. I'm going to say triangle ABC is an isosceles right triangle because, and now I have to describe why is it a right triangle. Why does my work justify that it's a right triangle? Well, up top here I showed that I had a right angle. So because I have a right angle, so because it has one right angle, and the two equal sides, and two congruent sides. And that's it. So the conclusion is the most important piece because now it's really summing up your work. Your work is all of your justification, but the conclusion really brings it all together and really justifies or gives your final explanation of why does your work justify that you have an isosceles right triangle. So like I said before, with this, if you had to just prove it's a right triangle, you would only do this first part and then you would go right to your conclusion. If you had to just prove it was isosceles, you would just do the second part. Usually we would do a third length as well just to make sure that we truly have an isosceles triangle and then write your justification. But since this asks for both, we do both steps. So that's it. So go ahead and check your understanding problem, get some key ideas written down, and we'll talk about those in class tomorrow.